Please be aware that everything that I show you in all of these precious metal recovery videos involves some level of danger. In the recovery and refining videos, dangers are going to be mostly related to working with corrosive acids, which also give off fumes, especially when reacting with certain metals. And so you want to either do all of this stuff outside or in a well ventilated location. If you're doing it inside, you really need a fume hood of some description. And when for gold melting and stuff like that, your risks are going to be mostly heat related, so risk of burning. Whatever you do, always make sure you've got adequate personal protection equipment. Okay, here we go.
Okay, so this is basically step one in the extraction of gold from the BGA chips from RAM. So I've got the oven turned up, I've got the RAM SIMs in there. These ones are heated up now. I'm gonna grab them, give them a whack so they're clean, chuck it in the box. The fingers of course will be removed from there, and yeah, just like this. It's just a matter of giving them all a whack. You end up with a nice bunch of BGA chips and some other mixed in little ICs and bigger ICs and things, but the BGAs are the ones we care about. We'll get the fingers from those later. They're much easier to remove now that all the chips and things have been removed, because I can just use the metal shear to cut them off. Yeah, so this is how I like to do the depopulation. It's by far the fastest. Okay, I'll be back. Okay, so here we have those that laptop RAM BGA chips after they have been treated with hydrochloric acid to remove all the solder, which is mainly the tin that we care about, from the bottom. I've got about 1 kilogram here in a this is a Milo tin. It's got a metal lid. And as you can see, I've drilled a few holes, just small holes in the side. I've just knocked those in with a screwdriver or something. And the objective here is to use a fire like that one. As you can see, I'm just heating that up a little bit. It's to use a fire to pyrolyze the chip. So what we're trying to do is we're trying to burn the plastic without the presence of oxygen. So instead of just throwing the chips in a frying pan and frying them up in the fire, we're going to turn that plastic into gas, which is going to come squirting out rapidly out of these little holes, which will then be burned up by the fire. And so you end up with the least amount of pollution that you can really do while you're burning plastic. It's only, there's not that much plastic in there, but this is by far the best way. So the first step is going to pyrolyze. I'll just wait for the fire to heat up a little bit more. You see I've got the hair dryer going into it there to generate a bit of extra heat. So as soon as that's ready, we'll put the chips in, and then once the gas starts shooting out the side and on fire, that actually looks pretty cool. So I might cut in for a quick view of what that looks like. Okay, I'll be back. Okay, so here we can clearly see the fireballs shooting out of the side of the can there, where the holes are on the right side of your picture. So seems to be working well. We're definitely vaporizing some gases. I'll basically just keep, and what I'm doing is I'm also turning the can side to side to try and spread the heat out evenly among all the chips that are in there. So at the moment the flames are shooting out the right hand side there. The can's getting pretty hot, so pretty soon what I'll do is I'll turn it so the flames should be shooting out the left. But essentially we want to keep on doing this until there are no more flames coming out at all. This has only been going for about 10 minutes or so, it's only burning wood, so it's a pretty cheap and effective way, and not causing too much pollution or anything that's going to cause you any problems with neighbors or anything like that. It's only wood burning, so which is still, being semi-rural here, is not really a problem. Okay, I'll be back. Okay, so here's a little trap for young players to be well aware of. Those holes that I poke in the can to let the gas escape and burn off, they tend to clog up with carbon and crap. And the problem with that, of course, is that you're going to build up pressure in your can and the lid's going to pop off and all kinds of disasters will happen, and your chips are going to fall in the fire. So it's good to just grab a longer screwdriver than this, or a long piece of wire if you've got one. And I'll show you, we've only got one decent hole working at this point, but if I poke this one, there we go. See how that started up now? Do the one in the middle. There we go. See, things are going much better now. So you've got to keep an eye on it and make sure, see how hot that is, it's pretty extreme. You've got to make sure those holes don't clog up, otherwise you're going to have problems. So just keep an eye, you can't just leave this thing, you've got to keep an eye on it and just make sure everything's going as it should. The other thing I haven't said, but I have been doing, is I grab some channel locks and I just turn the can about a quarter of a rotation every couple of minutes, so that all the chips heat up evenly, but also I don't want the can to melt in any one point for being left in the airstream too long. So just grab some long pliers or channel locks or something and just give it a turn every now and then. Cool. Okay, so when those chips come out of the pyrolysis stage, you'll see they are still quite black. They sound, I don't know, hard to describe. They don't sound the same anymore. They sound kind of, they've got a bit of a hollow sound, because we've driven off probably a lot of the mass using driven off a lot of the mass by driving off the plastics. You're kind of left with dried out carbon instead of plastic. So the next step is, while they're still black, they've still got carbon, and that's not what you want. So you've got a stainless steel pan on the fire at the moment, and you can see they're starting to go gray and white, and you really need to keep doing this until all of it is gray and white. You don't want black stuff in there, because black stuff is carbon, which is going to trap gold later on. So you can see there's, try and get a bit closer, it's quite hot here. You can see that they're going quite nice and white looking. That's what you're looking for. So just slowly go through, burn off all of the carbon like that. You can also use a gas torch from above, that works really well as well. But seeing as I've got the fire running anyway, pyrolyzing some more chips at the bottom there, you can see them happening there. I might as well, in my case, just use the stainless steel pan on the fire. So that's the next step, is burn the carbon until it's all burned up and basically just ash. Okay, so we've got most of those chips burned to a grey white color now, and what I'm going to do is I'm going to empty this into my secondary holding container like so. Get all the dust, that's the stuff you actually want. We'll just cover that for now while I describe the process. So obviously the unburned chips are going to go into there and go back on the fire now. I'm going to use a large spoon to scoop some of the white chips into this small hand-sized metal can with a big magnet on the top. So we'll scoop them into there. That is going to get shaken for a few minutes until obviously we're trying to break up that stuff as fine as possible. Then I'm going to use this bucket as my final capture bucket, which is also where I'll be washing the dust away. And I'm going to use my relatively coarse sieve. It's really hard to tell you how coarse that is, but I'd say each little square is about 1 millimeter by 1 millimeter, so that's 40 thousandths of an inch by 40 thousandths of an inch. So that's going to go onto there. Once I've shaken it, I'm going to remove the lid with the magnet, and anything stuck is going to go into my magnetic stuff tin, which I've got there. I'm going to work that stuff through the sieve until it's powder in the bottom. Anything that doesn't go through the sieve is going to go back into the shaker tin. It's going to get a few more minutes of shaking. It's going to get sieved again, and anything that doesn't go through the sieve the second time, which is by that stage mostly silicon dyes and stuff like that, is going to go into, I'm just going to demonstrate it here, but it's one-handed, but this is my silicon dye tin. So, and that's pretty much it, and that's the the process for getting to the dust. I'm not going to demonstrate how I do this because it's really hard to hold my phone and video while I'm doing it, and I'm just going to end up losing more of the stuff. Of course, you're dealing with quite fine powders here, so at the moment I've got my gloves on as usual, but I'm also wearing a really fine, like a asbestos type dust mask, just to keep the, keep your lungs protected. Your health isn't worth a few grams of gold. So yeah, that's the process, and then I'll keep on doing that until I've gone through everything in my tin here. And then what I'll do is I'll get to the washing, and I'll show you how we do the washing and process from there. Okay, I'll be back a little bit later. Okay, so I'm just busy here sieving some material, and I thought what was very cool is obviously this stuff hasn't been burned enough yet, so there's quite a few more black bits, so this is going to go black for a second burning. But if you look right there, you can actually see some gold bond wires. How cool is that? So you can actually see, so those are the little wires we're chasing, and you can see the size of the wires compared to the size of the sieve there. Luckily I've got this phone which actually works pretty well for this. Let me just see, I did see some other bond wires in here as well. So this obviously, yeah, you can kind of see them. Let me just find my bearings here, right there. Nope, that's not what I'm looking for. Kind of hard to, there we go, that's what I was looking for. See the little tangle of gold bond wires there in the middle? So that's the stuff we're looking for. Very cool. So yeah, this stuff is obviously going to go back for a second burning, and I'll just keep on burning until I've got all of those bond wires released, and keep burning, keep sieving. But yeah, the gold is there at least. Okay, so here we now have all that that fine sieved ash that came from the burn chips, and I'm just doing the first stage of washing, which is I've just got it all in like a little 5-liter pail, and all I'm doing at this point is it gets a little bit of, get some water filled up to about 3/4 or 2/3 or something like that. Shoot the water into the bottom so it agitates all the powdery stuff at the bottom. Then I just use a bit of a stir stick to make sure I get all the lumpy stuff from the bottom, because what you want now is you want all the ash and powder and stuff that's in there to be in suspension, because the gold bond wires are very dense for their volume, so they're heavy. And so you agitate, get everything in suspension, and the gold bond wires are going to fall to the bottom quicker than the rest of the stuff in there. And then I just basically count to 10, and then I tip off about 3/4 of the water that's in there and just leave the rest in there. And we're just going to keep on doing this until the water starts coming out. This is now just the second wash. This stuff is relatively safe at this point. It's mostly just burnt carbon. So that's not going to be a problem to just tip out on the lawn here. It's not like we get drinking water from there or anything, so it's no problem. So we're just going to tip this out without tipping out any of the powder that is still in the bottom. Sorry about the wind noise. There we go, about that much, and you can see the powder stuff, and you can even start seeing some copper and little bits of little shiny bits of silicon dyes that made it through the mesh. Okay, I'll keep on doing this until it's relatively clean, and then I'll transfer it to a beaker, and hopefully at that point I should be able to show you some gold in the bottom of the beaker. Okay, so I've transferred that relatively well washed material to a beaker here. And the reason that I like transferring it to this beaker is you can now give it a stir. And I think that unfortunately the amount of material that I got from 1 kilo of chips is a little bit too much to demonstrate this well in a 1-liter beaker, but you get it as agitated as you can, and then you just let it settle for a little bit. Not very long, because the gold is so dense. And then if we look at the bottom of the beaker and we get it to focus, you can clearly see how easy it is to pick out the gold. It does drop much faster than the silicon dyes or anything else that's in there. So I'll give this a couple more washes and then we'll move on to the next stage of this process. Okay, so we've got this ore material relatively well washed now, and we've already had a look at the gold that you can see that's kind of dropped to the bottom, because that's the really fine stuff, and the really fine stuff drops to the bottom really well. But even if you have a look very carefully at the top, and hopefully that's going to focus well and I can keep it steady enough, you can see the longer gold bond wires, like those ones right there, and you know, you can look around this and you'll see little bits of like they're tangled up gold bond wires like that. So yeah, that's pretty cool. Basically, I think I've done enough washing now. We're still left with you know, maybe 100 mils or so of material. There's still a fair bit of gold colored stuff that's dropped to the bottom, but yeah, next step is going to be getting rid of all the base metals from this, so I'll be back soon. Okay, so here we have the leftover, this is the washed particles that came from the BGA chips, and I've shown you the little bit of gold that's visible on the bottom, and I've also shown you the gold bond wires that you can actually see in the middle of the material. And the next step is basically going to be, so we've washed it out fairly as well as we can with water, and the next step is going to be to try and remove as much of the base metals as possible. And because we haven't actually had any of this stuff anywhere near hydrochloric acid, the easiest way to wash out the base metal is going to be to add some nitric acid to it. Nitric acid is really good at diluted nitric acid, especially really good at getting rid of the copper and stuff like that from it. So it's not super visible, but I filled that up to about the 200 ml level with distilled water. You want to use distilled water at this point and not tap water, because the chlorine in tap water can make a weak aqua regia solution, which will then start dissolving some of your gold, which is not ideal. What we'll do anyway is we'll add some nitric acid to this, let it do its job until it's completely finished. And obviously in this case, I'll zoom out a bit so it's visible, I'm working in the fume hood, and there is a extraction fan right there above the where the reaction is going to take place. Obviously also it goes without saying, when you're working with concentrated nitric acid, eye protection and hand protection are no-brainers. Okay, so let's go. So got about 200 mils of water there. Might add 100 mils or so of nitric acid. Your dilute nitric acid works better on things like copper, and dilute acids are also more efficient. So as soon as acid touches anything, you're creating waste, and you want to obviously create as little waste as possible. There we go. Instantaneous reaction. I'm just going to turn on the extraction hood. There we go. And so, well, obviously that's going to get rid of a lot of copper, and the copper is quite fine, so we've got a pretty reasonably vigorous reaction there. Bit of a, you can feel how much less dense all that stuff in there is already. Obviously you also want to be doing this kind of stuff in borosilicate glass, because the temperature increases fairly rapidly when you're doing this. And realistically, if I was more intelligent, I probably would have added in smaller quantities of nitric acid over time. So it's fairly silly to just add in about 100 mils or 80 mils or so, as I did there. So for future reference, add your nitric in smaller increments and get a less vigorous reaction. But overall, we came off right here. It's still reacting very nicely. Okay, and then obviously once the reaction is finished here, I will be cleaning, just basically washing out the nitric waste, which would then contain quite a lot of copper, so I'm expecting it to be fairly blue as it already looks there. And that's going to go into my waste container after I've tested it with stannous chloride to make sure that there's no diluted, no gold in solution there. And then keep on adding more nitric until really there's no color change and no reaction. And after that we're going to go to aqua regia to dissolve the gold, which should be left at that point. Okay, that's it. We'll be back a bit later. Okay, so I've washed that, so that first batch of nitric acid has had a good long time to work and the reaction stopped completely. So I've washed it off out a few times with distilled water, and we're about to give it the second run of nitric acid. This time I'm being a little bit more intelligent about it, so we're starting with about 45 ml or so. I'm just going to turn on the fume hood. We're just going to add a little bit in and just see if there's any reaction still happening. There's very little reaction, like no visible reaction happening with that 20 mils of nitric acid, which is very nice, because that's telling me that we've pretty much now eliminated the base metals, or the base metals anyway, that will react with nitric acid or dilute nitric acid. So what I'll do is I'll just give it another couple of hours just to sit there. It's not, the hot plate isn't on, but it is catching a bit of heat from the solution that's evaporating next door, so it can just sit there for a little bit, and just in case there's any base metals left, let them react out. And then what we'll do is we're going to aqua regia that sucker and dissolve some gold. Okay, so here we've got the filtered and washed and treated with nitric to get rid of all the base materials, leftover bits from the RAM BGA chips, and I can see visibly with the naked eye, as I've shown in the previous part of this video, quite a lot of gold bond wires that are kind of clumped up, which is always a very good sign. If you can actually see the gold, you're doing pretty well. So the next step is going to be for us to make aqua regia to dissolve the gold. So I've got it on the hot plate. I've got my 33% hydrochloric acid ready to go, and I'm only going to, it's got about 150 or so milliliters of distilled water already in there. Going to add about 100 milliliters or so we might fill it up to about the 300 millimeter mark of the hydrochloric acid, and then I am going to let the whole solution heat up to about 60 degrees C, which is where aqua regia likes to react. And initially I'm not going to put any nitric acid in, because there's still going to be some leftover trace nitric acid in the washed out solution there. But so we might see that it might turn golden yellow all by itself, but there's nowhere near enough nitric acid left in there to actually dissolve all the gold that's going to be in there. So so later on, once everything's done its business, we're going to start adding nitric acid slowly. So I'm just going to turn on the ventilation here, because hydrochloric acid fumes a little bit. And we're going to slowly fill it up. We'll give it about and there's actually a fairly vigorous reaction happening already, because the hot plate had already heated the water that's in there to about 60 degrees, and so you'll see that's leftover nitric acid. Not sure if, yep, that's quite visible on the camera, is actually reacting with the hydrochloric and the gold, and we're putting a fair bit of gold into solution there. That's actually much more reactive than I was expecting. I thought it would cool it down a bit with the hydrochloric, Obviously good to have the ventilation, and what I might do is give it a little bit of a stir to make it all mixed up, and then we'll just put the watch glass on, because there's no real reason to evaporate off any of the solution at this point. Okay, so I'm going to let that reaction run its course there, and we'll be back a little bit later to look at putting some more nitric in there to until there's no more visible gold. When you're doing something like this, the tendency is always going to be to put too much nitric in because of the risk of leaving gold behind, which is probably what I'm going to end up doing as well, and then that's just going to have to be dealt with in the evaporation stage. You'll see the color of the aqua regia there is not very good. Obviously I haven't removed 100% of the base metal, and I also haven't washed out 100% of the nitric that's reacted with copper solution, but that's part of life with the kind of dirty reaction we're doing here. So what's going to happen is I'm going to go through the process and then drop the gold out of that aqua regia, and then I am going to refine that gold to get it up to a reasonable purity. But that'll be some other day's problem. So yeah, I'll be back a bit later. Okay, what was left of the nitric acid in solution appears to have reacted very happily. Where solution is currently sitting at about 70 degrees C, and I know of course that there's still plenty of gold in there, because if I just do that, you can actually see the clump of gold bond wires kind of in the center of the screen there, and so I know we're still well away from having dissolved all the gold. So from now on, my 70% nitric acid is going to go in using a pipette like this. Let me just zoom out a little bit for you here. Oops. There we go. So from now on, use a 3 milliliter disposable pipette, and I'm going to give it I'll probably start with a few 3 millimeter shots of nitric. So it'll get a shot of nitric, and then I'll give it a half an hour or 20 minutes or so of a little bit of stirring to dissolve away, and then we'll do the next 3 milliliter, and then eventually, once I start getting to the end of the visible gold, I'm going to drop that down quite a bit. The reaction is nice and vigorous here because I've thought about it, and the gold bond wires are actually producing a very nice fine surface, a lot of surface area, and so you get a very nice reaction out of it. So we're going to give it another 3 milliliters or so, and not so much visible to you guys through the fog. Oh, there you go, you can actually see the reaction happening. It's actually still happening very nicely there with those gold bond wires dissolving. I'll move them a bit closer to the, there we go, look at that mess of gold bond wires right there. That's amazing, that's massive. So I might leave those there, and we can actually just keep an eye on those, which will give us some idea. But that's still reacting quite vigorously, which at this point is a very nice thing to see, because of course the more reaction we're getting at this point, seeing as we've removed the majority of the base metals, the more reaction we see at this point, the more gold there is, or precious metals there are left over in that solution. So that's looking great. So we'll just give that 20 minutes or half an hour or so, and then I'll come back and do the same, and we'll just keep an eye on that big floating mass of bond wires. They're floating of course at this point because the reaction is causing gases which are caught up in the bond wires and causing them to float like that. So very cool. Okay, so after about a day or so of slowly adding nitric, about a milliliter or so at a time. We've there, as you can see, we've got the ugliest gold bearing chloroauric solution that anyone has ever seen. Pretty horrible green, dark, muddy color. That presumably is going to be either due to something that was on the silicon dyes, some kind of treatment, or it's going to be some base metals that didn't react to the nitric, or it's going to be some other precious metals. I know when you obviously dissolve pure gold or close to pure gold, you end up with a nice, beautiful yellow golden solution, but either way it doesn't really matter. That is still a fair bit of gold in a solution there. That's cooled to room temperature now. So what I'll be doing is I will now be decanting that solution into my evaporation container. Okay, so after a fair bit of wondering what I'm going to do with the BGA, the sieved BGA material that has been dissolved in the aqua regia, I decided in the end that instead of just trying to decant it and wash the aqua regia away from the leftover material that way, that I'm just going to filter it, because I think it's going to be easier to get everything in the filter and then wash through the filter with either distilled water or hydrochloric acid. And so yeah, we'll see whether or not this ends up being a good idea. So I've got the material here. Sorry if I'm going to be blocking the view a bit. I've let it settle quite a bit, obviously, so the sediment is mostly at the bottom, so filtering initially should go pretty easy. I don't have a very large excess of nitric in here, only a fairly small excess of nitric, which means that the filter paper should hold up okay. So I have done, and in fact the color of the aqua regia is not actually so bad once you get it away from all the dark material in the bottom. It's not perfectly golden like you would like, but it's not too bad. So unfortunately, with what I'm doing here, we are going to end up with, so this is just a water rinse now. Unfortunately, with what I'm doing here, we're going to end up with quite a bit of solution that needs evaporating down, but that's just a necessary evil. So I'm just using 2 coffee filters there. I always use 2 coffee filters. So next I think I'll be doing a hydrochloric acid rinse of the leftover material, and then maybe 1 more or maybe 2 more water rinses, and then that's going to be pretty much it. And then hopefully all of the crap will be left in the filter, and we'll end up with some aqua regia that can be evaporated down to get rid of the nitric acid. Okay, so I'll come back a bit later when I've transferred to the evaporation container. Okay, so as you can see here, I've got my pregnant chloroauric acid solution, my gold in solution, basically transferred to my evaporation container now, and I've got it on the hot plate. And so with your evaporation container, there are 2 things that are critical, that make a big difference to how long it takes and how well it works. The first thing is you want something with a very large surface area. You know, that's a massive opening, which means that it's got nice surface area for evaporation. And the second thing is you want something with a flat bottom. Trying to evaporate it in just beakers like this does not work well, because the bottom is domed convex, which means that the evaporation just doesn't work as well once it gets right down to the bottom, because you can't swirl the mixture around very well because it stays in the corners. And basically you want to evaporate your gold bearing solution down to the point where it becomes more viscous, so almost syrupy. And then what we're going to do is we're going to add some concentrated hydrochloric acid, and we're going to do that a couple of times at least, and that is going to remove the nitric acid from your solution then. So yep, this is going to take, we've got about 1 liter of solution at the end of the day there. That's because I used a fair bit of hydrochloric acid and water to wash the gold solution from those fine silica parts. And so we've got a reasonable solution there. You'll see it's kind of looking a little bit better than it did when we just had it in the beaker. But yeah, that's where we're at now. So this is going, I'll come back when it's got to the syrupy point and I'm about to add in some more hydrochloric acid, but that's going to take a long time. We're at about 1 o'clock in the afternoon now. I expect maybe tonight at about 8 o'clock or something like that the 1 liter would have evaporated off. The other thing is we want to control the temperature of the solution to about 80 to 85 degrees. Going too high causes little bits of boiling in the solution, which then you'll end up having some brown powder in the bottom of your solution, which is the gold boiling out of solution. So what you want to do is just keep it at the 80 degrees C level or something like that, so the evaporation happens a little bit slower, but you don't have that problem of your dirty gold kind of coming out of solution before it's supposed to. So I always use a nice glass thermometer in mine and give it a stir every now and then and make sure that temperature stays more or less where I want it to be. Okay, we'll be back later on today. Okay, so my timing from earlier today was pretty spot on. It's almost 8 o'clock at night, and as you can see here, the volume of the solution has been dramatically reduced. We've gone from something like 800 milliliters down to just a little puddle in the bottom, and this is the reason why you want a nice flat bottom, so you can swirl it around like this. And this is about the point. You can also see how nice and yellow the light shining through it is. It does look a bit dark, but the darkness comes mostly from a bit of fine crap that managed to make it through that initial filtering. So it's not too bad, but this is about the point where I like to add a little bit of hydrochloric again. So at this point we're probably going to give it about 100 mils or so of hydrochloric, basically just a splash. I'm not going to be too precise about it. There we go, about that much. And now we're just going to leave it again to evaporate down again. Obviously it's going to take a wee while, so I'm going to do this. I've done this, this is now my first hydrochloric refill. I think I'll do at least one more hydrochloric top up and let it evaporate down, and then we should be ready to proceed to the next step in the refining of this gold. But so far everything is going relatively well, all things considered. It's looking pretty good. It's not nearly as bad as it looked earlier on today. Okay, I'll be back a little bit later on. Okay, so this solution here has now gone through 3 evaporations, and I'm fairly sure we're going to be rid now of most of the nitric. So this time around things are going to happen a little differently. I've turned off the hot plate because we now no longer want to actually heat that solution up. I'm once again going to now add in a little bit of hydrochloric acid. It's probably a little bit too much. It doesn't need to be, that's probably like 200 mils or something. It doesn't need to be anywhere near that much. And we'll just give it a little bit of a shake. And one of the major changes now, so we're going to take it off the heat, and we are going to add some, I'll just leave it in the shot for the moment. We are going to add some ice now, so I'm going to add probably Oh, you know, make up your mind. Probably I'll go for 6 or 8 or so ice cubes to that, because we now want to cool that solution down nicely so that we can get rid of any salts, mostly because salts tend to be not as dissolvable or solvable, I'm not sure what the right word is, but in cold solutions, and so they'll precipitate out or drop out of solution if we cool it down. So I'll quickly grab some ice cubes and get those in there, and then I'll be back. Okay, here we go for some ice cubes, cool that solution down. The second purpose of the ice cubes is also to add water to the solution, because the next step, after we filter the solution, we're going to drop the gold out with some sodium metabisulfite, and that step actually does require there to be water in the, if you do all of your washing with hydrochloric acid, and you end up coming to the point where you're trying to drop the gold out and you haven't added any water, the pH is too low and the gold will not actually drop out of solution, which is quite surprising, because you think the objective is to create sulfur dioxide by letting the hydrochloric acid react with the sodium metabisulfite. But yeah, if you don't have water, the whole thing doesn't quite work. Okay, so I'm going to take this off the heat now. Let the ice cubes melt and then cool down the solution, and then I am going to filter the remaining solution. Now there is obviously some brown powder a little bit in there, and there's no way at this point of knowing, without adding nitric, which obviously we don't want to do because we've just spent a whole day getting rid of it, there's no way of knowing whether that brown powder is gold or not. So we're going to assume that it's not, and we are going to save the filter anyway, so I don't throw away any of those filters if they've got any kind of black or brown powder, and they go into my filter container and they'll go into a future aqua regia somewhere. Okay, so the ice is mostly melted, everything's looking really good here with my aqua regia. I'm sorry about the bad light. It's dark outside obviously, so we're not getting any natural light, and the lights that I've got rigged up in my fume hood work quite well for what they're supposed to do, but not perfect. Okay, so now because we've got a relatively concentrated solution, I'm going to try quite hard not to lose any of the solution in the filtering. Even losing little drops that fall off the end of my container here would be, you know, a very real loss at this point. And so, so I've just gone for 2 coffee filters again. Hopefully this time we can catch a bit more of that black brown stuff that got through on the last round. It's probably very fine silica or silicon from those dyes from the ICs that got through the last filtering. Okay, so yeah, it's dropped in there, and obviously at this point use your spray bottle with distilled water, and make sure you wash every last little bit of solution into that cup. Water at this point is not a bad thing, keeping in mind that the more you dilute stuff, the more waste solutions you're going to be creating. But yep, I'm pretty happy with that. That's clean and clear, that's looking good. So we'll put that one out of the way. Now I'm going to let that filtering finish, then I'm going to use my spray bottle obviously to spray all solution, kind of spray the filter until it's not yellow anymore, essentially to try and get as much of that that gold bearing solution into the 1000 milliliter beaker as possible. And then we're going to gently warm that beaker up again. It doesn't have to be cold at that point. We'll be quite happy to get that up to 30 degrees or so before we do the dropping out of the gold with the sodium metabisulfite, but I'll demonstrate that a little later after I finish the filtering here. Okay, I'll be back soon. Okay, so there is the filtered chloroauric solution, and as you can see, it's got a little bit of a green tinge to it, so there's obviously still a little bit of copper left in there. It's not too bad actually on this load, and I think what we'll find is once I've dropped out the gold, we're going to end up with a light blue solution, which is going to be indicative of the copper. In this other beaker right there, I've got 12 grams of sodium metabisulfite dissolved in 200 milliliters or so of boiling water, hot water, and now we're going to have a go at dropping out this gold. If it all works as it should, it's a very beautiful reaction because it's going to go relatively quickly, quite muddy and dark from that very nice crystal clear solution. So the tendency that you're going to want to do is to stir the solution and at the same time add in that sodium metabisulfite. The problem with that is that the gold then tends to plate out on your stir stick, and I've made this mistake once and ended up with a very nice bit of gold plating on the stir stick, which is not the objective here. We actually want the gold powder to drop, to be in suspension and drop out. So what I'm going to do is I'm going to stir the solution just to get a bit of agitation going. Then I'm going to drop in the sodium metabisulfite and give it a few seconds, which it appears to be working, and then I'm going to start stirring again. And there you have it. That's basically a textbook gold drop, and I might be speaking a bit early, but I think it's going to be a relatively good gold drop as well. There is already a fair bit of gold visible on the surface, and that's quite a nice dark reaction. Now obviously I'm doing this right in front of the fume hood, even so I can still smell the sulfur dioxide, so you want to be able to do this in a ventilated place or the fume hood. I'm just going to get my gloves off, as I won't be touching anything. So you'll see there quite a dark solution and a little bit of gold floating on the surface, which is not ideal. It means that my glassware that I thought was very clean actually wasn't perfectly clean, but not too bad. So now the next step is essentially just to let this solution settle overnight, but even so, you can see the little bits of gold dropping off the side. Even so, it actually seems to be settling quite well. And first thing I'll do tomorrow morning is so obviously we're going to cover this to keep any crap out of it, and the first thing I'll do tomorrow morning once the gold is settled out is I'm going to test some of that solution with some stannous chloride to make sure that we've dropped all of the gold out of there. I think 12 grams of sodium metabisulfite should do it. If there was still a little bit of nitric present though, it may not have completely done it, in which case the sodium metabisulfite would have neutralized some of the nitric, in which case we still will have some gold in solution to drop out. So I'll probably, before I show anything else, after this you probably see me showing the test of the solution that's left over with the stannous chloride. Okay, we'll be back tomorrow morning. Okay, so that solution with the gold dropped out of it, that one there, settled really well overnight, and that's looking quite good. that's ready to be to have the acid decanted and the gold washed and recovered from that. But first we have to do a stannous chloride test to confirm that all the gold has been dropped out of that solution. So what I've got here is my chloroauric acid supply. So this is just stuff that, I'll put a little drop in there. This is just the stuff that if I find a few foils left, you know, from other processes and stuff like that, any basically excess gold that I've got that isn't part of a big process somewhere, just goes into this one bottle, and over time, one day I'll get around to actually dropping the gold out of that as well and recovering some gold from the bottle. But it generally doesn't contain much gold, which makes this a very nice test, because we've got this control sample here to prove that my stannous chloride is still good, because it does go bad. Now we're also going to grab a drop of that solution. In fact, I'm going to get a big drop, because you know, we really want to see if there is a result. And I can already see by how clear it is, you can actually see the color difference just even in those white spoons. Now obviously at this point you've also realized that I much prefer the white spoon method for doing this test rather than the paper towel method or coffee filter method or whatever. The white spoon method is far superior in my opinion. So we'll zoom in a little bit more, and these plastic spoons cost next to nothing anyway. Okay, so we're going to give the control solution a single drop of stannous chloride, which is just elemental tin that's been dissolved in hydrochloric acid, and you will see an immediate reaction there. And we are going to give the other solution a drop too, and you will actually see no reaction, which is very good. So this is going exceptionally well, all things considered. We'll give it a little bit of a shake. There is actually, I'm going to bring it right up, but I think the problem is focusing. There is actually a little bit of a reaction there, nowhere near as obvious as this one. Sorry about the crappy focus. Nowhere near as obvious as that one there. But I'm not too fussed about this, about seeing this reaction here. The reason I'm not fussed about it is that, I'm going to zoom out a bit again here, all of my decanting of the spent fluid from my solution there is going to go into this container here, where I'm going to give it another day or so for all the any tiny particles of gold that make it over with the decanting is going to have another day to settle. Just remove these. Have another day to settle out of solution in this pot here, and then, as a matter of interest, let's just go back a step. The reaction of stannous chloride looks quite reddish, which I think is actually a indicator for platinum rather than the purple we expect for, or the dark stain we expect for gold. So either way, decant into this container here, which then gives it another day or two for any tiny little bits of gold that wants to settle, and then afterwards, of course, what's going to happen is that that gold's going to get washed into this pregnant chloroauric acid solution again, because that's where it comes from, is all those little bits of leftover gold. I try and capture, you know, any metallic gold in there. And the second purpose of this is that I'm going to evaporate it down, because a lot of that is, the vast majority of what's in here at the moment is water, and also of course some precious metals in solution, like your platinum and your palladium, and, you know, things that I haven't dropped out of solution. And so that then, once it's evaporated down a bit, is going to go into my stock pot, where those things get cemented out on copper, and in the end the copper replaces the platinum and palladium and everything else that's in solution here, and the copper then goes for further waste processing to get the copper out of solution. But the nice thing is I end up with a stock pot you know, that'll process in 20 years or something, that's chock full of proper precious metal. Okay, so for the decanting step, let me make a little bit of space here. Obviously I'm still working just outside the fume hoods because this stuff still does fume even though it's fairly spent. You will find there's a tiny amount of floating gold on the surface, and I recommend having a really good quality misting spray bottle. I also have this one here. Now this type of spray bottle has the power of the red sun of Krypton. It's a very powerful bottle, but its spray function is crap because it's so powerful. So I also have this one here which I use for misting, and you'll see, you might be able to see, makes a really nice fine mist. So if you hit the surface of the solution with a little bit of fine mist, it knocks most of that powder down, and it will settle. Anything that does get decanted into here, not a big problem anyway, because as I said, after another couple of days it will definitely settle in that one. So with your decanting, you want to be absolutely as gentle as you possibly can after this has already, of course, settled overnight. Now this solution of gold actually did settle really well, surprisingly well. I think this is probably, for some reason, the solution that I've had that has settled the best. I hope that's an indication, that's a good indication and not a bad indication if the gold settles really well. I am, oops, that's a little bit of a hiccup there. I am of course combining the waste material from more than one process here, but that's okay. This is all stuff that's come off gold, so it's all stuff that's going to go into my stock pot anyway. It's interesting noting the green color. I would have expected once I dropped the gold out to actually to end up with a yellow color, sorry, a blue color, because I've dropped the yellow out, but I'm still quite green. And that's interesting, you know, we're kind of suggesting that there might be iron in there at this point, which is it's not a problem to put iron in the stock pot because it's quite reactive compared to everything else, so the iron won't get displaced, so it's not really a problem, but it's just interesting more than anything else. Okay, there's a little bit, so I've gone to the point, and you'll see it's kind of hard to picture the amount there, but that's a decent quantity of gold. Obviously later on, after I've melted it and stuff, I'll let you know how much I actually ended up recovering in this part of the process. But that's it. Now I've got this spot here, which a little bit of that dust will still settle out of, and you can give it a mist every now and then on the surface just to knock anything down. And also this is now just going to go onto a very low hot plate, and this can just sit there slowly evaporating and concentrating the waste before I put it into the stock pot. So now we have gold powder. The next step is going to be to wash the gold powder, and so I'll show one wash with boiling water because it's pretty boring. We're going to add, let's say 100 ml or so of boiling water to this gold. I'm going to pour it gently into the side far away from the gold because I don't want to make the gold go up into suspension again. I really want to keep it you know, nicely bundled, and also kind of try and collect any of the straggling bits of gold into, because it does tend to clump quite well at this point, and that's what we like it clumping. So it's going to get boiled with water a couple of times probably, then I'll boil it once or twice depending on how the color looks with hydrochloric acid, and it doesn't have to boil very long. A couple of minutes with a gentle boil is probably good enough. And then 2 or 3 rinses with distilled water again, like boiling distilled water, and the object of that of course is to dissolve any salts that might still be in there. And then just basically decant all of that into my waste container, and then dry the gold on I like to use an old school dripping coffee machine for drying it, because I can just leave it on there and forget about it, and it doesn't overheat the glass or anything like that. And yeah, then I won't, and then we'll go from there. Okay, so I'll be back a little bit later. Okay, so here you can see how I prefer to do my my washes of the gold powder. So I prefer to do it with a like a camping gas burner using a ceramic heat spreader, all the while working over my catch bucket in case anything goes wrong there. But I find that the hot plate is a little bit slow for this process. Using gas like this is much quicker to because you want to kind of keep it boiling for about 30 seconds or a minute or so, just long enough to get any of the salts that are left in there. And yeah, so I'm just going to finish this washing process, but this is the basic setup that I use. And if it should be obvious, but there is a there's a watch glass on top there, as you'll see. So you want to you want to contain the heat. You're not trying to evaporate anything off at this point. Any of this wash water and wash acids are also going to go into my waste container that's being prepped for the stock pot, of course, because there's going to be a tiny little bit of gold that goes with the liquid every time you decant like this. But yeah, I'll finish the washing up and come back after that. Okay, so after what feels like an eternity of work, I washed all that gold powder and I melted the button down, and here is the gold shot, and this is what everyone was probably waiting for. So looking quite good, nice color, little bit of a inclusion at the top, which seems pretty standard for pretty much anything I melt. Only pain is there's a little black, it's kind of hard to see, but there's a little black mark right there on the side where I think a little bit of the black paint from the tweezer that I used to pluck it out got into the gold, which is a little bit unfortunate. But let's chuck it on the scale here, and we've got about 6.5 grams of 6.58 grams of gold there, which by anyone's reckoning is a really nice amount of gold to have recovered. Having said that, it was quite a lot of work, and so it's probably still worthwhile, but quite a lot of work into it. So yeah, hopefully this was a useful video to someone, and good luck with your gold mining.